So I've been asked to express the integral in terms of gamma function. And then once we have the solution, deduce the value of the limit of the integral as k approaches infinity to have a solution or a value of 1. So let's demonstrate. So the first part of the equation, you have the integral of k, integral in terms of k, 0 to infinity, e raised power minus y power k, dy for any positive value of k. Now, by definition, we'll do some transformation to this integral in order to be able to evaluate within the limits 0 to infinity. So let us say u to be given by y raised power k. Remember, k is a constant, so which means that du is given by k y raised power k minus 1 dy. So which means dy will be given by du over k y raised power k minus 1. So replacing, we'll have integral in terms of k. Now the limits as, remember this, y approaches 0 or y is 0, then u is also be 0. And when y is infinity, also u will be infinity because this is a positive constant. So therefore limits do not change. So the integral from 0 to infinity, e raised power negative. So where there's y raised power k, we put u. And then dy, we put du divided by k y raised power k minus 1. But then, since this is the value of u given by y raised power k, then we can write this one as integral. Actually, I can factor it out 1 over k. And then I have e raised power negative u times y raised power 1 minus k, then du. So which is the same thing as remember, to get y alone from this substitution will be y. You raise both sides to 1 over k, which would be u raised power 1 over k. So this can be written as 1 over k integral 0 to infinity e raised power minus u times this y power 1. So this can be written as y power 1 times y raised power minus k. So which is the same as y is the same as u power k, 1 over k, and then u raised power negative 1, and then du. This is the value of u power negative 1 is the value of y raised power negative k. So which will give us 1 over k integral from 0 to infinity of u raised power 1 over k minus 1. Now using loss of indices to these two terms, two values of u, e raised power minus u, and then du. And you see this integral here is simply the structure of gamma of 1 over k. So this is the same as 1 over k, gamma of 1 over k. So therefore, I, for the integral given, is simply 1 over k, gamma of 1 over k. Now, the second part was to show that the limit as k approaches infinity of this integral I gives a value of 1. Now, limit as k approaches infinity of this integral I will be given by limit as k approaches infinity. Now, I have already in the first part calculated the value of the integral. So it'd be 1 over k, gamma of 1 over k. Now, we also know the fact that if I have gamma of x plus 1, is the same as x gamma of x. So which means if I have 1 over k, gamma of 1 over k, is the same thing as writing gamma of 1 over k plus 1. So just taking x to be 1 over k. So this limit will be limit as k approaches infinity of, now instead of writing 1 over k, gamma of 1 over k, I'll write gamma of 1 over k plus 1. And then clearly, as k approaches infinity, then 1 over k approaches 0. And so 1 over k plus 1 approaches 1. So therefore, limit as k approaches infinity of this integral integral I is the same as limit as k approaches infinity of gamma of 1 over k plus 1, which is the same as gamma of, now as k approaches infinity, it will just be gamma of 1. And gamma of 1, by definition, is given by 0 factorial. Remember, this is the same as 1 minus 1 factorial, which is just 1. Note that we are using the fact gamma of x is the same as x minus 1 factorial. So gamma of 1 is 1 minus 1 factorial. 0 factorial is 1. So therefore, the given result for that integral I should be 1 as deduced in second part. Thank you.